Hey guys, this is Miss Harris. I'm reviewing for the Math 150 College Algebra Unit 2 test for Miss Meador's class. It covers mostly quadratics, like vertex, axis of symmetry, x-intercepts, y-intercepts, opening up and down, how a graph finishes and starts, vertical asymptotes, horizontal asymptotes, and domain. So I'm going to try to go through one of the practice tests I printed online from one of the practice tests. There's 19 questions. I'm going to try to go through them thoroughly. You probably can't see this. Also, I'm going to try to make sure there's a PDF sent out to you that has the solutions like written out as well. But I'm going to talk you through the steps here, and I'm going to use the whiteboard underneath this paper to rewrite the problems and hopefully make it bigger where you can see this time. I also am going to have other lessons like that break down into like groups like quadratics, how graph finishes, vertical asymptotes and horizontal asymptotes and domain. So I'm going to have those as like little mini lessons to give other examples as well. That way you'll have more to go on than just the one example from this practice test. All right, let's go. Number 1 says find the vertex of the graph of the quadratic function. It gives you the quadratic function. So to find the vertex of a graph, first you have to find the x value of the vertex of the graph. There's a formula for that. The x value of the vertex of a quadratic function is always going to be x equals negative b over 2a. Now, the equation given to you, f of x equals 2x squared minus 8x plus 10. All right, you got to know your ABCs. Your A is your leader, your leading coefficient. Your B is your middle coefficient, -8, and your C is +10. Make sure you get the sign that goes with the B. So it's really important here that you use parentheses. This is negative b over 2a. Now you can type it on the calculator. I'm probably going to do most of the calculations just the long way, but I would advise you to type it in the calculator because calculators don't make silly mistakes like we do sometimes. So you can just type all this in the calculator. You're going to get +8 over 4, which is going to equal 2. So right now for the vertex, you need an x and a y. You already know the x. So how do you find the y? To find the y, you plug it back into the function, f of x. So where x is, everywhere there is an x, you're going to put parentheses. Parentheses are really important, especially when you have negative numbers. All right, so we're going to put a 2 in for x. We're substituting it in. All right, now I highly recommend you type all of this in the calculator like you see it with parentheses, okay? It's faster for me to just do without a calculator. 2 squared is 4, 4 times 2 is 8, -8 times 2 is -16, plus 6, you got back it up, Terry. 8 minus 16 plus 10 is -8 plus 10, which is going to be a +2. So when x is 2, f of 2, that means when x is 2, y is 2. So we get the vertex 2, 2. Make sure it's in as an ordered pair with parentheses. All right, question number 2. Yours may be in a different order in your test. I don't know if they're in the same order like by content. And you probably, most likely will have different numbers. But as long as you follow the formulas, you should be good. Number 2 says find the vertex of the graph of the quadratic function y equals -3, parentheses x minus 3, quantity squared plus 6. Now, this is already in what they call vertex form. Vertex form is y equals a, parentheses x minus h, quantity squared plus k. Notice this a is the same a in standard form. Standard form, this is going to be important later, is y equals ax squared plus bx plus c. That's where we got the a and the b for the x value of the vertex, -b over 2a. This time, let me back up. The leading coefficient is always the same, whether you're in standard form or vertex form for a quadratic. Now, the reason why vertex form is nice, it shows you the vertex. The vertex comes from here and here. What's inside with x is the x value of the vertex. So the vertex is going to be positive h, because when you bring it out, it changes signs. When you bring it out of the parentheses, it changes signs. And then the y value of the vertex is going to be k out here at the end. So this problem is actually one of the easiest problems on the test, as long as you remember when you bring something out of the parentheses, you change the sign. So question number 2, I have y equals -3, x minus 3, quantity squared plus 6. My handwriting hasn't gotten any better. All right, so the x that comes out of the parentheses with x, that's the x value of your vertex. It's going to be +3, and your y value is going to be +6. It's just pattern. Math is just patterns. I do want to talk about, since the leading coefficient is negative, we know that this parabola opens down. Okay, concave down. That's going to show up in other places on the test. All right, let's go to question 2. Sorry, that was question 2. Let's go to question 3. Question 3 is going to give you a graph, all right, and they're going to ask you for several different things. It says, from the graph of the parabola, determine whether the parabola opens upward or downward. Well, this is upward. Find the vertex. It's showing you the vertex. The axis of symmetry, I'll show you what that is in just a moment. And a range of the function. Range are the y values. Find the maximum minimum value of the function. That means how high or how low does it go on the y-axis, and the intervals on which the function is increasing and decreasing. So just to make this bigger, I'm going to recreate this graph real quick. I'm sure mine will be much better than theirs. That's called sarcasm. All right, so I'm going to go over here to 1, -9. That's the vertex. And it's showing you a couple of x-intercepts here, 2, 3, 4, and 1, 2. And the parabola's doing a little something like that. Okay, so let's see which questions they want us to answer. All right, it says the parabola opens what? Well, it opens up. Hopefully we don't miss that. At least I got one right on the test. All right, vertex. Vertex is the lowest or the highest point as an ordered pair. So we want the point. It tells you to type it as an ordered pair. Make sure you look at little details like that. 1, -9. Now the axis of symmetry, I'm going to not hate and abbreviate here. The axis of symmetry is the vertical line that divides the parabola in half. Okay, that's horrible, but you get the idea. So if I were to crease right here and fold the parabola, there would be a mirror image on both sides. That's why it's called an axis of symmetry. The axis of symmetry is a vertical line, which is x equals a number always. And what does x equal right here? X equals 1, all up and down that line. So our axis of symmetry is x equals 1. All right, next it wants range. The range are the y values. Remember domain and range. Domain, range. D comes before R in the alphabet. X comes before Y. All right, so we were looking at Y. So the y-axis goes up and down. So how low down does the parabola go? It goes down to -9, and it touches there, so we're going to use a bracket. If it can equal, use a bracket. And then it goes up forever to infinity and beyond. Buzz Lightyear's here, y'all. All right, so that's the range. If it asks you domain, domain goes left and right. This parabola goes left forever, it goes right forever, so that would be -infinity to infinity. Okay, I think next is increasing and decreasing. All right, so kids struggle with this. Now, they always put increasing first, it seems, and decreasing second. So they're wanting to know, like, over here on the graph, if you read the graph from left to right, that's the way you're supposed to read it. It goes down, that's decreasing, and then it goes up. So actually, it's good for you to visualize this axis of symmetry because it's what cuts the graph in half from decreasing to increasing. So where does the graph start increasing? Well, it starts increasing right here and goes up. Now, this they're wanting this and x values. What's increasing and decreasing are the y values. So you're reading left to right. So from 1 to infinity, the graph is increasing. And it touches at 1 to infinity. Okay? On the left side of the axis of symmetry, the graph is decreasing. Now, what x value is it for? You have to read left to right. So all the way to the left is negative infinity. And then, so here's x. So from negative infinity all the way to 1, the graph is decreasing. All right? The question wants to know, it's asking, is there a minimum or a maximum? So the first one says, what is the minimum value of the function? Well, the minimum's right here. But you got to know it's wanting just the y value, because this is like up here, this is low. It's talking about max min in the y direction. So the minimum is going to be -9. The maximum, there is no max because it goes up forever. So you would say the function, it's a multiple choice here, the function has no max. All right. Oh, sorry, it actually asks for minimum, maximum, and then increasing, decreasing. Got my cart in front of my horse there in Crofton. Okay. Ready to move to the next question, which is question 4. All right. And guys, I encourage you to stop the video, rewind as many times as you need to. That's probably the biggest pro of not being in person. But if you're in person, you can stop me and ask questions. So question 4 says, identify the vertex, axis of symmetry, y-intercept, x-intercepts, and opening of the parabola, then sketch the graph. Well, that's a lot. So let me rewrite the equation up here. The equation is f of x equals x plus 2 quantity squared minus 9. All right. Now, this is in vertex form already. I notice my leader is positive. The leading coefficient out here is positive, so it's going to open up. I know that. All right. And the first thing it asks is the x-intercepts are. Personally, I would have asked you to find the vertex first because the vertex is easy to see right now. The vertex is going to be -2. Remember, when you bring it out of the parentheses to change the sign, and then whatever y is what y is, -9. You're going to have to know that in a minute. Now, the next thing it asks for are x-intercepts. The x-intercept is the value of x when y is 0. The value of x when y is equal to 0. So we want to set this thing equal to 0 and solve for x. The problem is, actually, I think I have a faster, I showed you a different way to do this on the handwritten one, but I just thought of an easier way. So let's do this. Let's solve for x. Let's move -9 to the other side and add 9. Trying to solve for x here. The opposite of squaring something is the square root. Now, when you take the square root and you're solving for x, the answer is not just 3 here. It's going to be plus or minus 3. And square root and squares cancel. So you actually have 2 equations. You have x plus 2 could equal 3, or x plus 2 could equal -3. Because when you take the square root, 3 times 3 gives you 9, but also a -3 times a -3 gives you 9. So you got to solve x plus 2 equal to positive and -3. So you're going to -2, -2, -2, -2. Make sure you use your calculator during the test. There's no sense making little mistakes. -3 minus 2 is -5. So your 2 x-intercepts are 1 and -5. Now, it wants you to write them as an ordered pair. So we're going to write x is 1 when y is 0, and x is -5 when y is 0. Those are your 2 x-intercepts. Real quick, if you're not awesome at calculating, like, well, that's the calculator calculates, but like algebra, and you make mistakes solving and stuff, you can always go to your y equals screen and type in the equation as you see it. All right, I'm gonna zoom standard. I don't know if y'all can see this. You might can pause it and zoom in or do a screenshot. Zoom 6. And you can see, looks like there's an x-intercept here and here. That's +1, -1, 2, 3, 4, 5. So you actually can get that off the graph. And really, I know that she's going to pick nice numbers here, so they're going to be integers. But you can also go to a table, second table. By the way, you should always set your table, second window. And let's just start at -5 since we already sort of know that there's an x-intercept there. So second window is your table set, -5 with a change of 1. That little delta means change. And hit second graph. And look, when -5 and 0, when y is 0, that's the x-intercept. When y is 0, that's the x-intercept. So that verifies it, and you can also just check your work like that. All right, it wants to know if it opens up or down. The leading coefficient's positive, it opens up, plus we just looked at the graph. There you go. Okay, so, oh, I guess I could have done that with the table. Look at that. So, on the table, you can see x when y is 0 at x equals -5 and x equals 1. All right, what else are they asking us to do for this? They want the vertex. So there's the vertex, -2, -9. The axis of symmetry. Now remember, the axis of symmetry is the line that cuts the parabola in half. So -2, -9, let's just say somewhere down here. So let's do a little something like this. We just graphed it on the calculator. So the axis of symmetry is this vertical line right here. Well, what does x equal right there? X equaled -2. It's the x value of the vertex. You can remember that. The axis of symmetry is always x equals whatever the x value of the vertex was, and here it was -2. All right. It also wants the y-intercepts. All right. So now the y-intercept is where it crosses the y-axis. It's the value of y when x is 0. All right. So we can do this. Hopefully you can still see this down here. Yeah, you can. So I want the value of y, that's f of x, when x is 0. So really we want to plug a 0 in here, because when x is 0, what is y? So we have 0 plus 2, quantity squared minus 9. In here we're going to have 2 squared. 2 squared is 4, and 4 minus 9 is -5. So the y-intercept is the value of y when x is 0, and it's 0, -5. You can also verify that on your calculator. If you go up here and you look at the graph, you can sort of estimate. It looks like when x is 0, we can sort of count down how many tick marks there are, but you can also look at the table, and when x is 0, y is -5. All right, and I think that's all for that problem. Next, number 5. All right. So number 5, let me erase all this. Number 5 is still on quadratics. It says write the quadratic function in the form y equals a parentheses x minus h squared plus k and sketch its graph. So it gives it to you in standard form. Okay, now I told you this a while ago, but I'm gonna reiterate. This is called vertex form. Okay, standard form, vertex. Standard form is y equals ax squared plus bx plus c. Okay, so they're giving it to you in this format. 4x squared plus 16x plus 20. Now, here's the deal. Remember, your leader is always your leader. So we already know that there's going to be a 4 here. So we got part of the problem done. And it's positive, so I know it's going to open up. Now we got to find the vertex, the H and the K. So we're going to use that formula that we did on number 1. We're going to find the X value of the vertex first. The X value of vertex. And that's the formula, X equals negative B over 2A. So negative of B over 2 times A. Your B, this is your A. This is your B. This is your C. Your B is 16. Hope y'all can see that. And your A is 4. Now, again, I would type this in the calculator. Alpha y equals, make a fraction. Use parentheses because calculators make less mistakes than we do. Negative 16 over 2 times 4, which is 8. So we're going to get an X value of negative 2. So now, let's go back over here. Right now, we know the leading coefficient. And now we know the X value of the vertex. But when we put it in, it's not still going to be negative 2. Anytime you go in and out of the parentheses, it's going to change sign. So this is going to be plus 2 right here. It's important to change your signs. Now, we still need to know the Y value of the vertex. And remember, once you know X, to find Y, you're going to use this equation up here. So to find Y, I'm going to plug in X or substitute in X. So everywhere there's an X, I need to use parentheses. You will get it wrong on this problem if you do not use parentheses. You will miscalculate. Even if you type in the calculator, if you don't use parentheses, wrong. Okay, make sure you square on the outside of the parentheses as well. It's something I see in my Algebra 2 students. All right, negative 2 squared is 4. 4 times 4 is 16. Oh, by the way, just type this all in the calculator. All right, then I'm going to do it old school because I'm old. 4 times 4 is 16. 16 times negative 2 is negative 32. Plus 20. We get negative 16 plus 20, which is going to be a positive 4. So the vertex was negative 2, 4. Now, they didn't really ask for the vertex. They said put it in vertex form. Well, look back up here. We had our leader, which was the same leader over here. Your leader is always your leader. We found X. When we put it in the parentheses, we changed signs. So now we're going to put Y right here. So Y equals 4, X plus 2, quantity squared. And your Y value is 4, and whatever Y is what Y is. It's not going in and out of parentheses. So there is the equation of the function in vertex form. Now, it says use the graphing tool to graph it on Math Excel. So what you're going to want to do, first you click on the little graph, and you're going to choose the parabola, which is a U shape. You're going to want to plot the vertex negative 2, 4 first, okay? And then I just use the y-intercept as my second point. The y-intercept is always the C. So like I went down and I clicked at negative 2, 4, and then I went up to 0, 20 and did it. Now remember, you have a graphing calculator, okay? So you can go to your y equals screen, type in the original equation. Don't type in your vertex form because what if you made a mistake? So type in 4x squared plus 16x plus 20. Now I'm going to zoom 6. So it's opening up. The vertex, look, negative 2, 4, okay? Now when you use the graphing tool in Math Excel, it's going to want you to plot the vertex and then another point. If you want another point, you can always get it off your table. And see right there, the y-intercept is the value y when x is 0, it's at 0, 20. And when I was looking on the practice that I looked at, it lets you actually go up to 0, 20. The graph is big enough to do that. You could have also, after you plotted the vertex at negative 2, 4, you could have plotted negative 1, 8 as well. And make sure you save your graph. All right. Question 6. Question 6, still on quadratics. It's just like the one before. It says write the quadratic function in the form of vertex form, y equals a parentheses x minus h quantity squared plus k, and sketch its graph. So we're going to take the equation, number 6, y equals 2x squared minus 12x plus 14. So I need the x value of the vertex. Remember, that's negative b over 2a. Negative stuff over 2 times stuff. Make sure you use parentheses. This time my a is 2 and my b is negative 12 and c is irrelevant on the x value of the vertex. So we have, again, type this in your calculator, alpha y equals, use parentheses. We got positive 12 over 4, which is going to be x equals 3. So right now on the vertex, I know x is 3. I still got to find y. So to find y, you're going to use your equation, y equals, and everywhere there's an x, guess what we're going to plug in? 3. Good answer. All right, so everywhere there's an x, we're going to put in 3. And again, I would type all of this in the calculator where you don't make mistakes. Double check it when you type it in. All right, so if you were doing this without a calculator, you're going to do your exponent first. 3 squared is 9. 9 times 2 is 18. Negative 12 times 3 is negative 36 plus 14. 18 minus 36 is negative 18 plus 14 is going to be negative 4. So now we know our vertex. We know the x before was 3, and now we know the y is negative 4. So what does that look like in vertex form? Remember, it's y equals a x minus h squared plus k. A is your leader. Remember, your leader is always your leader. Okay? Our x was 3. Now, we're not going to put 3 here because we're going in the parentheses. We're going to put minus 3. Remember, you go in or out of the parentheses, you change signs. And then whatever y is goes at the end. You do not change signs there because you're not going in parentheses. This is the vertex form of this parabola. You can graph this on the calculator. It's going to open up because your leader is positive. We already know that 3, negative 4, 1, 2, 3, 1, 2, 3, 4. It's doing a little something like this. I will tell you, it crosses the y-axis up here at 0, 14. How did I know that? Because c is 14 and that's the y-intercept. It's the value of y when x is 0. If you put a 0 in there, 0 in there, you get y is 14. Remember, you can graph this and use your table to plot your points. You need 2 points to do a parabola on Math Excel. You click the parabola button, you plot the vertex, 3, negative 4, and then you pick another point. I would pick 0, 14. You can get those off the table on your graphing calculator. Okay, number 7 on the test that I pulled up online is a word problem. Now, y'all freak out over word problems, but normally the math is not any more difficult than other problems. It's just knowing what they're asking. And the print here is really small, so I'm going to read it to you a little slower. It says, if a football is kicked straight up with an initial velocity of 64 feet per second from a height of 4 feet, then its height above the earth is a function of time given by h of t, height as a function of time. Negative 16t squared plus 64t plus 4. What's the maximum height reached by this ball? And then it says, hint, find the vertex of the graph. Yeah, you got to find the vertex first. So all these words up here, you really don't need those. They're giving you the function, and they want to know the maximum. Remember, a maximum or a minimum is where the vertex is. The equation on this function, h of t, equals negative 16t squared plus 64t plus 4, okay? Your leader is negative, so we know it's a parabola opening down. That's why there's a maximum, okay? Now that maximum is going to be the y value of the vertex. So before you can find the y value of the vertex, you got to find the x. Now, some of you may be thinking, well, there's no x or y in this problem. Well, t is taking x's place. H of t still stands for y. So I'm just going to keep with x right here, even though it's a t. We're using negative b over 2a. Negative of whatever b is over 2 times a. A is negative 16. B is 64. So negative of b, negative of 64 over 2 times a, 2 times negative 16. Type that in the calculator, okay? So I get negative 64 over negative 32, which makes a positive 2. So I know the x value of the vertex. So this is going to be 2 and some y. The maximum height is the y value. Remember, y goes up and down. The height of the parabola is y. So how do you find y? H of t is y. So we want to find the h of 2, the height when when t is 2 or when x is 2, same. So everywhere there's a t, we're going to plug parentheses in. And we're going to put in a 2, substitute in. Again, please, I encourage you to type this in the calculator. So 2 squared is 4. 4 times negative 16 is negative 64. 2 times 64 is 128 plus 4. This is going to be 64 plus 4. It's going to be 68. So when t is 2, at time 2, the height is going to be 68 feet. That's the y value of the vertex. The vertex is at 2, 68, and the y value is the max height. All right. So that word problem is really easy. You just take the equation, find the vertex, and then use the y value for the maximum height. Okay. Question 8. By the way, that was question 7. All right. Question 8 is asking for the symmetry of a quadratic function. It says describe the symmetry of the graph of the polynomial function. And it gives you to you in standard form. By the way, the leader is positive, so it's opening up. And it says it's not symmetric, and it's about a line x equals, about the y-axis, about a line x equals, about a line x equals. Now, so what we need to do is find the vertex. Actually, we don't have to find the whole vertex. We just have to find the x value of the vertex, and that's the axis of symmetry. Okay, so number 8, the axis of symmetry is going to be the x value of vertex. Now, we've used this on almost every problem so far, so you should know it by now. X equals negative b over 2a. We might need the equation. The equation is y equals, well, it's f of x, same thing, 2x squared plus 16x minus 8. So we want the negative of whatever b is over 2 times a. Parentheses are important. All right, our a and our b, a is 2, b is 16. So 16 and 2. Type that in your calculator. Don't be too prideful. Alpha y equals, make it into a fraction. We get negative 16 over 4, which is going to be a negative 4. That's the x value of the vertex. That's what's going to split this graph in half. So the axis of symmetry is x equals negative 4. And so on my choice, that's choice B. Hey, by the way, you could also just graph it. I mean, seriously. Let's graph that. Let's graph that. If you're not one of my students, I apologize. I do crazy stuff like that in class, like it's a game show. Let's graph that. All right, so I'm typing in the equation 2x squared plus 16x minus 8. I zoom 6. So here's the parabola. You can't really see the vertex. If you want to change your window, you can change your y minimums down to like, I don't know, negative 20. Oh, not low enough. Well, anyway, we know that x equals negative 4. But look, their choices are negative 8. Negative 8's right here. So obviously that's not an axis of symmetry. Positive 4 is a choice. That's all the way over here. It definitely has symmetry down the middle of it because it's a parabola. So A is not going to be a choice on multiple choice. And it's definitely not reflecting over the y-axis. So process elimination. Don't hate, eliminate. All right, let's look and see what number 9 is wanting us to do. Okay, number 9 gives you we're out of quadratics right now, and we're on to a cubic function, x to the third. It says find the x-intercepts, describe the behavior of the graph of the polynomial function at the x-intercepts. Now, first thing, you can graph this. Let's graph that. All right, I hope there's not a glare there. We're going to go to y equals, and we're going to type in x to the third minus 5, whoops, forgot the minus, minus 5x squared. All right, zoom 6. Aha. So the graph increases, decreases, increases. And it wants to know about the x-intercepts. This is the x-axis. So there's an x-intercept here and here. It touches but doesn't cross, and it looks like it's 0 to me. I don't know about y'all. And then here it crosses at that value, 1, 2, 3, 4, 5. So remember, the x-intercept is the value of x when y is 0. So if you look at your table, it's the value of x when y is 0, 0, 0. The value of x when y is 0. So my two x-intercepts are 0, 0, and 5, 0. And it crosses at 5, 0, and it touches and turns back at 0, 0. Now, I do want to show you how to do that algebraically. You do have to factor. I don't know how proficient some of you are in factoring. Factoring is a really big prerequisite. Say that 3 times real fast. It's a big prerequisite for college algebra. Hopefully you know how to factor. This is the binomial. What I notice is they both have an x in it. And not only an x, this has an x cubed and x squared. So we're going to do a greatest common factor here of x squared. So we're going to take out an x squared. Now, factor means divide. So x cubed divided by x squared is x. X squared divided by x leaves you with the negative 5. If it only looked like a 5 and not an s. Okay. So we just factored this binomial. It has two factors, x squared and x minus 5. Technically what you do is you say, when will x squared be 0? Square root at 0. When will x minus 5 equal 0? Add 5, add 5. There's your x-intercepts. 0, 0, 5, 0. Remember, the x-intercept is the value of x when y is 0. Now, I don't have my students do this middle step. If it's in parentheses and you bring it out, it changes signs, so 5. There's nothing added or subtracted to x. What's nothing? 0. Now, I will tell you this, and I don't really have time to teach it all out, but this x plus 5 is to the first power. It's an odd root. If it's an odd root, it's going to cross through the x-axis at 5. So it's going to actually cross through at 5. Because the plain x is squared, it's an even root. In pre-cal and calculus, we call that a double root or an even root. It's going to touch and double back. So when it was increasing, it touched, double back, came down here somewhere, and did a little something, something like that. All right, so those are your two x-intercepts. You're supposed to separate them with a comma. Make sure you read the stuff in parentheses because it'll remind you how to write your answer. You can lose points by not typing your answer incorrectly, as I'm sure some of you know. Also, the graph crosses at 5, 0. The graph touches but doesn't cross at 0, 0. Okay. So question 10, probably one of the easiest questions on the test. I don't know. They're all easy to me. That's rude of me to say. Okay. It gives you the function f of x equals 4x to the 7th. Ooh, do it big now. Minus 6x to the 6th plus 5x to the 5th plus 8. All right, it's one about what it does to the left and to the right. This is called in behavior, okay? And it wants you to use the leading coefficient test. I have a video that I'm going to upload. I've already done the video, and hopefully it'll be sent out at the same time as this review. So first, you have to tell how a graph finishes. How it finishes first. You have to tell how it finishes first. This is the start. This is the finish, okay? You read left to right. So you have to look at your leading coefficient. We played follow the leader as a kid. My leader's positive. I'm going to finish positive. So we're going to finish positive. But what does that mean? So that means over here it's doing this. So that means it's going to rise to the right. So it's going to rise right. And remember, you have to tell how it finishes first. After you tell how it finishes, then you can tell how it starts. Okay, so finish, you're looking at leading coefficient. Starts, you're looking at the degree. Okay, so the degree of this function is 7. The degree is the highest exponent. Now, 7 is odd. Odd means opposite. So since it finished positive, we're going to start opposite of that. What's the opposite? Negative. Okay? If this had been an 8, 8 is even. Even means the same. So if it finished positive, it would also started positive. So you tell it finishes first. If your leading coefficient is positive, it's going to finish positive. If your leader is negative, it's going to finish negative. You look at degree to tell how it starts. Odd is opposite, so since it finished positive, it's going to start negative, which means it's going to be doing this, which means it's going to fall left. I honestly don't like the way college algebra does this. I do it a little differently in pre-cal, but it's all good. Okay, if you probably need more examples on this, so check out the video on in behavior of functions. All right. Number 11 says match the polynomial function with its graph. So does number 12. Guys, go to your y equals screen, type it in, match the graph. I'm not going to waste time on that. Okay, now we're to some good stuff. Find the domain of the rational function. Now, domain means there's a restriction. We have to look for any restrictions on x, okay? So let me remind you that there's 3 big things we can't do in math. 3 things you can't do in math. And some of you are like, there's a lot more than 3 things I can't do in math. All right, the first thing you can't do is divide by 0. You can't do that. All right. Hey, that looks like a smiley face sideways. Anyway, can't divide by 0. You cannot take the square root of a negative number or an even root of a negative number. They do become imaginary, but you can't do it and get a real answer. And then 3, you can't take the log of 0 or the log of a negative number. So when you're looking for domain restrictions, you're looking for one of these 3 things. On your test, it's just going to be divide by 0. So that's what I'm going to focus on today. So domain means x. Remember, domain and range, they're in alphabetical order. So is x and y. So domain is x. So what can x be? So hopefully x can be all real numbers unless we have one of these 3 things, okay? Well, in this problem, we have division, okay? So I'm going to rewrite the problem. F of x, this is question, what question was this? Question 13 on my test. F of x equals negative x squared plus x all over x squared plus 3x plus 2. If you had me for pre-cal, we spent, a long time on functions like this, doing domain, vertical asymptotes, horizontal asymptotes, and holes in the graph. Now, we can't divide by 0. So here, fraction means divide. So I need to find out when this denominator equals 0. So I'm going to factor it. Okay? So I do not have time to teach you factoring right here. If you don't know how to factor, you can go to Khan Academy and Google factor a quadratic trinomial with a leading coefficient of 1. Factor a quadratic trinomial with a leading coefficient of 1. Flip Math is also a good resource. It's probably in Algebra 1, honestly. So I got to multiply to get a positive. Either they're both positive or both negative. Middle sign's positive, so they're both positive. I'm multiplying to get 2, adding to get 3, so that's 2 and 1. 2 plus 1 is 3. 2 times 1 is 2. I could factor the top if I want to. I don't have to here, but just for fun, I'm going to factor out a negative x That's how you would factor that. Factors like undistributing when you have a binomial. So I factored this because now I know the two things x cannot equal. X can't be -2 and x can't be -1. Why? Because if you plug -2 in here, -2 plus 2 is 0, and 0 times anything is 0, and we have to divide by 0. Same thing with -1. So x can be any other two numbers but that. So we have to tell the domain in interval notation. So we're going to start at -infinity. So our graph can go from -infinity to what's the smallest number it can't be? -2. Use parentheses here because you cannot equal -2. Make sure you use your U symbol, that means or. Then we're going to go from -2 to 1, sorry, -2 to -1, or -1 to infinity, parenthesis. Now, that seems complicated. It is if you don't know how to factor. Let me give you this little bit of advice. You have a graphing calculator, hopefully. If you don't, you should get one. So I'm going to go to alpha y equals, no, sorry, let me get out of there. I'm going to go to y equals first, clear out anything that's in there. And I'm going to go to alpha y equals and make a fraction. And I'm going to type in my numerator, -x² plus x. My denominator is x². Whoops. It's hard to do this holding this up under the camera. Let me just start over there. I apologize. Oops. Clear. Alpha y equals fraction. Let's try that again. -x² plus x over x² plus 3x plus 2. Zoom standard. If you've already zoomed standard, you can just hit graph. Now, I want you to notice a couple things. You can tell there's some type of issue right here. Little crazy. Make sure I type that in right. -x² plus x² plus 3. Okay, I got it. All right. So it looks like around -1 or -2, something weird's going on. You actually can't see the whole graph. There's actually more going on down there, but that's irrelevant. Let's look at a table because we know there's weird stuff. Look what's happening at -1 and -2, an error. So if you struggle on this problem with factoring the denominator, go to your graph, or graph it, and then go to your table and find where there's an error. That will be what x cannot equal, okay? So your y values, your x values go from -infinity to -2. There's actually values in between -2 and -1. I can try to show you. Let's see with that. Yeah, this is a crazy graph. There's stuff going on down here that we can't see. See, professors know that. That's why they pick these problems. But if you look at your table, wherever the errors are, that's what x can't equal. But look, there is some graph in between -2 and -1. So this part right here is really important. So if these are the only two values x can't be, start from the far left, -infinity, go to -2, then go from -2 to -1, and then go from -1 to infinity. You've included all numbers except for -2 and -1. We're using parentheses because it can't equal. All right, I wish I had you in class where I could teach you more about that. It's really not that bad, but factoring is really vital. Okay, question 14. It says determine the domain and the equations of the asymptotes for the graph of the rational function. Watch your mouth, asymptotes. Okay, so they give me this graph, and I don't know if you can see it. Okay, I'm going to attempt to redraw it to make it bigger where we can talk about it. Well, I'm talking, you're just listening. Sorry about that. So there's a vertical asymptote at 4, and it looks like at 1, 2, there's a horizontal asymptote, and it looks like it's doing a little something, something like this and like this. I mean, My graph's not as great as theirs, but it's all good. So first of all, it asks for domain. Remember, domain is x. So this graph goes left forever. X is in the left and right direction, by the way. This is x, this is y. It goes left forever and it goes right forever, but there's a discontinuity in the middle. Actually, that's called infinite discontinuity. So our x's go from negative infinity until we get to 4, and then Houston, we have a problem. So it goes from negative infinity, comma, to 4. And then it starts again on the other side, so you say or 4 to infinity. Now you might say, well, it doesn't look like it gets close to 4. Okay, this denotes an asymptote. What an asymptote is an imaginary line that the graph approaches but never touches. It gets super, super close but never touches it. So as x gets closer to 4, y is increasing forever, and as x gets closer to 4 this way, it's increasing forever, but it never touches when x is 4. Okay, so that's your domain. The vertical asymptote is here. Remember, vertical is up and down. So x equals 4. Make sure you write the equation. It tells you in parentheses. The horizontal asymptote, don't hate, I'm going to abbreviate. That's this. You just count on the graph they give you, and it's y equals 2. This is x. Look, what x is it crossing? X equals 4. That's how you can know which equation is. What y is at? All the y's here are y equals 2's. All right. And then I think it asks you, no, that's all it asks you. There's no slant asymptotes there. I don't think that's going to occur on this test, honestly. All right, number 15 is going to give you a function this time, not a graph. And it wants you to give the equation of any vertical asymptote. So number 15, they give you 5 over x minus 2. Okay, remember we can't divide by 0. Well, when will this be 0? Well, it'll be 0 when x is 2. So x cannot be 2. 2 minus 2, 0 divided by 0. So there's something wrong going on at 2, okay? If this factor does not cancel with anything on top, then that's where the vertical asymptote is. The vertical asymptote is at x equals 2. Now, so this confuses students. Well, Ms. Harris, you just said x can't be 2, but then you said x equals 2. This is the domain. X can equal all real numbers. It can go from negative infinity to 2 or from 2 to infinity. But it can't be 2. Well, what's going on at 2 then? There's a vertical asymptote. When you graph this on your calculator, and I'm just going to do it by hand real quick. Okay, you've got this going on right here, and the graph looks like this. Just to save us time, okay? So when you graph that, now on the calculator it doesn't show the dotted line, it just shows this. But if you use the table, there's going to be an error at 2, and you know that it looks like that, so that's the vertical asymptote. All right, number 16 asks you about horizontal asymptotes. All right, I plan on doing a separate lesson on horizontal asymptotes, so I hope I can fit that in tonight. 16, it says give the equation of any horizontal asymptote for the function. Okay, so here's our function, 4x plus 5, x minus 2. All right, quick summary. Horizontal asymptotes, you're going to be looking at the degrees. You're going to be looking at the degrees of the top and the bottom. Up here, the degree is 1 because it's x to the first. Down here, the degree is 1. Okay, so there's 3 rules, okay, for horizontal asymptotes. If the degree of the top is greater than the degree of the bottom, then there's no horizontal asymptote. If the degree of the bottom is greater than the degree of the top, it's y equals 0. Always y. If the bottom is bigger than the top, it's always y equals 0. And 3, if the degree of the top is equal to the bottom, it's going to be y equals the ratio, it's a 0, ratio of the leading coefficients. Now that sounds complicated, it really is not. Okay, look, there's my horizontal asymptote lesson in 1 minute. So if you're, look, I had a student, his name was Niall Shimwell, shout out Niall. He graduated, a minute ago, about 2013. He came up with this, he said, Miss Harris, this is how I remember it. So guys, I'm gonna teach it to you right now. So we're talking about asymptotes. That sounds like a bad word, right? Asymptotes. Horizontal asymptotes, okay? So think a body. If your top is bigger than your bottom, so you got a top and a little bottom, you don't have a bottom. No horizontal asymptotes. If your bottom is bigger than your top, you got a big O bottom and a little bitty top, big O bottom, big O, y equals 0. Big O bottom. All right, but if your top and bottom are the same, you do have a top, you do have a bottom, and they're the same, they're proportional. What is a proportion? It's a ratio. Ratio of the leading coefficients. So shout out to Niall for teaching me that, and it's helped my students learn ever since. So up here, let's go back up here. The degree of the top is 1, the degree of the bottom is 1. When your top and bottom are the same, you do have a bottom, you do have a horizontal asymptote, and it's the ratio of your leading coefficients. My leading coefficients are 4 and 1. So my horizontal asymptote on number 16 is y equals 4 over 1, which is just y equals 4. And you have to type it in as equation, and it's a horizontal line, which is y equals a number. Okay? Question 17. We're almost done, y'all. Oh, it just says find the graph. So 17, it says find the graph of x over x minus 2. You're going to graph that in your calculator and match it. If it needs you to graph it, it's not going to. It's a multiple choice, I'm pretty sure. Yeah, it is. Okay, 18. That means we got 2 more questions, but they are loaded, okay? I just got a low battery thing. I hope this thing's still going. All right. Number 18. Find all asymptotes, including all asymptotes, x-intercepts, y-intercepts for the graph of the rational function and sketch the graph. Okay, so we have number 18. We're given a function. All right, so we're going to do asymptotes first. You have vertical asymptotes when your denominator equals 0 and it does not cancel. You have a vertical asymptote when the denominator is 0 and it doesn't cancel. So when will our denominator be 0? Well, at -4. So actually that's a domain restriction. X can't be -4, but that's because there's a vertical asymptote there. So we have a vertical asymptote at x equals -4. Okay? It wants horizontal asymptotes. That's where you look at your degrees. Okay? So my degree of my top is 1. My degree of my bottom is 1. If your top and bottom are the same, you do have a bottom. It's going to be the ratio of your leading coefficients. So we have a 1 over a 1. 1 over 1 is 1. So y equals 1 is my horizontal asymptote. There is no slant asymptote for this. Oh, they don't call it slant. They call it oblique. There's no obliques. All right. And remember, we can graph this on our graphing calculator. We'll do that in a minute. But it says, what are the x-intercepts? So the x-intercept is the value of x when y is 0. So if you let y be 0 and you solve for x, you would multiply both sides by x minus 4 to get rid of the fraction. As I like to say, get the f out of here. Okay? So 0 times anything is 0 equals x minus 2. You're going to add 2 to both sides. That is your x-intercept. Now, whenever you have a fraction, you can just take the numerator and set it equal to 0, and that will always be your x-intercept. So the x-intercept, type it as an ordered pair, 2, 0. All right, that's your x-int. Getting a little messy there. I'm trying to hurry because my battery's dying. Now, the y-intercept hopefully you can still see this, the y-intercept is the value of y when x is 0. So in the equation, we're going to find the f of 0. Everywhere there's an x, we're going to put in 0. So if I put a 0 in here and a 0 in here, I get -2/4, which is going to be -1/2. That's the y value when x is 0. That's the y-intercept. So x is 0, y is -1/2. That's the y-intercept. All right. And then it wants you to choose the graph. You can graph that on your calculator and match it up. That's pretty easy. Okay, last problem. Can I get a whoop whoop? All right. So last problem, it says sketch the graph of the rational function. Note that the function is not in the lowest terms. Find the domain first. Okay. I know there's one thing x can't be on this problem, and it's 3. I can tell that by looking. You maybe can't see it. Here's the function. Remember, we can't divide by 0. When will this be 0? When x equals 3. So x cannot be 3. 3 minus 3 is 0. That's a domain restriction. So your domain is x. It can be any other number besides 3. So think -infinity to infinity, but we got to break it at 3. So we go from -infinity to 3 or 3 to infinity. Okay? And then it wants you to sketch the graph. Now, what's going to happen is when you graph this thing, it's going to look like a line. Let's graph that. All right, so I'm going to go to my y equals. Let me go and type it in, it'll make it faster. Alpha y equals, make a fraction, x squared minus 9 over x minus 3. I hit graph, and I got to redo it because I didn't zoom standard and I had changed my window a while ago. Now, it looks like a straight line. Okay, so look. You can definitely eliminate the one with the vertical asymptote. Is it a straight line? A lot of students will pick that. You should know it's not just a consecutive line because we know something weird is happening at 3. Now look at these two graphs. This one has a hole here, which is over here at x equals, looks like +3. This looks like at x equals -3. See how they're trying to trick you with that -3? Okay? But if you also go to the table, you can see in the table there's an error at 3. So there's a hole in the graph at x equals 3, which is going to make the choice C because there's a hole when x is 3, there's no y value. Okay? Now, I would also, so the answer was C on that, but I would like to tell you this. I want to show you this real quick. If I had time, I would teach you. If you factor out the numerator, it's the difference of 2 squares. These x minus 3's cancel. If they cancel, they're gone. In pre-cal, we say if they're gone, that's a hole in the graph. Now, where's the hole in the graph? It's at the restriction in the domain. When you have a restriction on your domain, that means there's one of two things happen. When you divide by 0, it's going to be one of two things happening. It's either going to be a vertical asymptote or a hole in the graph. If the factor cancels, it is a hole in the graph. Okay? As on previous examples, like this one, let's just say x plus 5. There's one thing x can't be. X can't be -5, the opposite of what's in the denominator, because -5 plus 5 is 0. So you either have a vertical asymptote or a hole in the graph. Since there's no x plus 5 to cancel, it's staying. It is a pain in the asymptote. It is a vertical asymptote at x equals -5. Okay. That's all I got for this review. I will see about uploading this. I will try to attach a PDF and hopefully a couple of other mini lessons on this stuff. Hope y'all do well on the tests. Don't hate, do great.